Okay, welcome everybody. This is operating systems. Not exactly the class I was going to teach today, but it's definitely the one we're going to have. So if you're brand new to ITU, then today is your day. I'm going to explain to you how the course is going to work. And this is how the course is going to work. This is the website here. It is www. In fact, let me go back this way, www.bhecker.com. So if you write down anything today, write down that URL, www.bhecker.com. Over here, you're going to find all of the course materials for this class, and you're going to find all of the assignments and the syllabus. I'm going to go over the syllabus today. I'm going to go over how the class is going to run. If you look down further down the screen here, you see this says Summer 2013. That's the link. You click on it. And then I have to change the dates here. I'll move this up and change it to well, this one here is going to go to here. Anyway, long story short, I got the wrong memo in terms of what classes we're offering when. At least I got the right classes, which is good. Just the wrong order, so this will change. But this is, if you click on Principles of Operating Systems, which we're all in here for today. Let me make this a little smaller so I can actually see it. What we got down here is the course syllabus, which I'm going to go over today, the assignments for the course, show you where everything is. I did prepare it, so we are all ready to go for this term. I do video record, and I'm recording right now. You can see there's like this little thing going up over here. It's called I Show You. It records everything on my computer and gets my audio. So if you miss a class meeting, you can certainly revisit, and it's all done on YouTube. And if you want, you can go back and you can see the previous videos, video lectures in here. These are all dated from 2011, several years ago. So I'll make a new link, and each one of our weekly classes will be recorded there. This is where you're going to find all of the materials. For those of you who are brand new to ITU, you probably want to make sure you get familiar with the EMS. That's where you're going to upload everything. So if you go into ems.itu.edu, you'll find that there's course listings in here. I don't actually have this course available yet. The course has not been built yet. Your interface might look a little different than my interface, but if I go under Summer 2013, I don't see it yet, but eventually you'll see the class in here, and then that's where you'll be uploading everything. But don't look for it yet, not available yet. So let me go over the syllabus so we know what we're into here. And the syllabus is located out here on the website. Hello. It's going to be right here, course syllabus, if you're looking for it. I don't print anything out, you know, so I'm all green, so it's definitely on the website though. Make this a little bit bigger so you can see it. So Principles of Operating Systems is a theory course. But there's a little bit of programming, but it's mostly theory. And so what we're going to be going through are all the different components that make up the operating system. So in terms of what you need for computer equipment, someone has already asked me. Any computer works. You don't need a MacBook. You don't need a Windows machine. In fact, you can probably take the course on a tablet. You probably want to do your assignments, however, on a computer. But yeah, there's nothing like in some of the other classes I teach, like for Android or for iPhone, where you're required a certain operating system. You don't need it for this class. So anything you want will work. In this class, we're going to cover the principles of operating systems. We're not going to look at different operating systems. Instead, we're going to look at building one. So what goes into the concept of creating an operating system? In terms of the system design, its implementation. So what are those things? Well, we've got concurrent process is the concept of the process. Inter-process communication, job and task scheduling. So we'll look at CPU schedulers. We'll look at scheduling issues. We'll look at common process issues in terms of deadlocks and starvation, stuff like that. Memory management. Talk about memory management in this course, segmentation, paging, auxiliary file storage, file systems, storage management, secondary, different types of memory, cache memory, main memory, secondary storage memory. All sorts of different types of memory management as well. So if we look at the course objectives down here, I'm not going to go through all of them, but looking at primarily focusing on the Linux and Unix operating system in terms of examples, because it demonstrates a little clearer, believe it or not, than looking at Windows or looking at the Mac. And when we look at Windows and we look at the Mac, we're looking at desktops, essentially. You're familiar with desktops. And so you can run a desktop on any operating system, essentially. But the Linux Unix operating system lends itself well as a good example of a base system to start with in terms of looking at it. But you don't have to have access to Unix or Linux, so it's a concept course. So, what are the required materials? This is the book I like. It's called Operating Systems Concepts. If I Google this guy here, you'll see the book is out in so many different forms. There's about half a dozen or so different versions of it. You can probably buy it for like $3 or something, $3 or $4 used. It's the dinosaur book. Here, we got $5 here, textbooks.com, you know. If you're brand new to computer engineering, computer science, software engineering, information systems, I don't know what your concentration is, but if you're brand new to technology and you come from healthcare or you come from MBA background or something of that nature, I actually highly recommend getting the book or a copy of the book. It doesn't matter what version of the book you get. This is kind of the godfather of operating systems, the author of this book, and most of my lectures come out of actually this version of the book right here with the dinosaurs on the cover. So it's called Operating Systems. If you Google the author's name, you'll see it here. This is one of the best operating system books out there. And there's no excuses. This is like $5. You can probably find an electronic version of it for free. Who knows? But I'm not promoting that. Long story short, if you want a book, there's a book. That's the book I recommend. But you don't need a book. None of the assignments come out of the book. None of the homework. Nothing comes out of the book. It all comes out of my lecture notes. So what do we have in this course? We have 10 what I call programming assignments. And each one of these assignments is worth 5 points each. And then we have 25% of the class is going to be on a final exam. Final exam is going to be given the last week of class. It's an in-class assignment and in-class exam. Closed book, closed notes, closed internet. You know, regular old college exam. Then I have this thing called a CSLO essay. It's just a writing assignment. So this stuff is programming. The programming assignments. We'll take a look at them in a few minutes. One of them is going to have you do a memory management simulation. The other one's going to have you do a CPU scheduler. Another one's going to work with deadlocks and processes. It can be done in any programming language that you want. And some of you are looking at me like, oh, what if I don't know anything about programming? Well, this is a great opportunity to learn. If you're software engineering, computer science, computer engineering, you're doing anything with an engineering at the end of it, you need to learn a little bit about programming, and this is a graduate level course, so it's not a bad idea to start now if you don't know anything about programming. So most of you have some programming background. If not, don't worry about it. You can take it at your own pace. All the assignments, everything's not due till the very last day of the term, which is about 15 weeks from now. So you have a long time, but don't wait till the last minute, actually. But I'll go over the first assignment, and we'll look at an example of how this stuff works. But what we have here is probably going to be a multiple choice kind of exam. So it's not going to be any programming on the exam, but it's a different way of assessing you. And then another part of the course is this essay, which is a writing assignment. So it's not going to be programming. So it's about 50-50. 50-50 on programming, 50% on writing, exam taking, stuff like that. We do uphold a pretty strict academic integrity policy here, academic honesty. And because we have had some problems in the past, we're particularly sensitive to issues of plagiarism, stuff like that. And because this book's been used by everybody, and some of the assignments actually come out of the book, very sensitive in terms of you know, people recycling things, especially from term to term, stuff like that. For the new people, you don't know what I'm talking about. For the old people, just be cautious. We will be, in fact, I think Turnitin is actually now part of the integration now. So, which means it'll automatically be plagiarized checks for you. So, if any two what this means, if any two students turn in the same assignment, or one that's very similar to each other, neither one of them gets any credit, and nobody else who turns in the same thing is going to get any credit. We had a few problems with this a couple terms ago. And people went, oh, when 5, 6 people turn in the same assignment, that's going to be a problem for you. So even if the assignment's not good, but you did it yourself, that's much better to turn that in because you'll get some points for it. Probably get full points for it. than if you turn something in that doesn't represent your own work. So it doesn't really matter if you're the creator of it or if you're the copier of it. The policy basically is for everybody, so it's a 0 on it, and there's no way of making it up. And then you got to go retake the class, and it's kind of a hassle. So not a bad idea, just do your own work. Long story short, that's the academic dishonesty policy. When we got the grading formula, there's no such thing as an A+ at this school. A is the highest grade you can get. This is a graduate school, so you probably want to get B or above in the class. If you do your own work, regardless of how good it is, I mean, there's expectations of how good it should be, but it doesn't have to be fantastic work. But if it's okay, meets the requirements, you did it yourself, you'll get an A in the class. Or we have the people who like to cheat and don't turn in their own stuff, or if you don't upload it to the EMS, or you wait till the last week and we have internet problems and you can't get it into the EMS and you have issues, you'll get an F in the class. So it's usually an A or an F kind of thing. So, and we do give out a lot of Fs, which is kind of amazing. So yeah, don't wait till the very last week of class, or don't wait till the 11 p.m. on a 12 o'clock p.m. midnight on the very last day that the class is open. Because you know what? If everybody else waited until that particular day as well, you're not getting in. You're not going to be able to post it before midnight. If you can't post before midnight, you're not getting any credit for it. So it's, especially when you have 15 weeks from the beginning of the course to do something. Anyway, that's all I'll say on that. Don't wait. Experienced people, the new people are the ones I'm talking to right now. The experienced people know, don't wait till the last day, because the EMS is going to go down. And then when it goes down, you're going to be stuck, and then you have to go back and forth, and tech support never calls you back, and it's just really a problem. So think ahead, and you'll be safer that way. Safer than sorrier. So what are we going to do? What we're going to do this week, and we'll probably end up getting out a little bit early today, because it's the first day. But maybe we'll go for like an hour, hour and a half. I think the class is supposed to run from 11 to what, 12:30 or? Oh no, we're not running until 1:45. For me, lecturing, about 2 hours is my max. So 11, 12, 1. We'll be lucky 12:31. We'll be out of here by 1. I think, that's right. Perfect time for lunch, actually, at that point. I'm going to be hungry. You're going to be hungry, Yeah, attendance, though, however, is required for this course. I think you have to meet 70% attendance in order to get a grade for this course. Is this all I have? I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 19 people? Well, we're going to have fun then. Usually, well, I know they made the classes a little bit smaller this term, but maybe it's a Monday at 11 a.m., which is the kicker right there. I sort of like that, though. You get in, you're done. After Monday, you're done for the rest of the week. Especially, are any of you in engineering management class? Yeah. Then we'll be, we'll have a long lunch break, and then we'll come back for. I think that class starts at 2. All right. So don't worry about lunch break. We'll have a lunch break between 1 and 2. And then at 2 o'clock, we'll go till 3, 4. 2 hours is really my max. We'll be out of here by 4, so you can plan your day accordingly. So really, if you're, working adult, I should just take Mondays off. That's about it. It's not that big of a deal. So, are you guys taking the weekend stuff? No, you guys don't do weekend classes. You're lucky. I'd rather do this than the weekend. That's why originally I'm like, we're not teaching EM, engineering management, on the weekend. That one's just too hard to teach on the weekends. So, all right. So the grading formula looks pretty standard. In here, I wanted to mention the reason why I brought up attendance is because although this does look pretty standard, there's nothing in the grade on attendance. However, if you don't meet attendance requirements, it's not me, it's the university. It's going to give you, I think, a D- in the class. I don't know why they picked D-. I'd just give you an F, but it's just the D- they give you. So, which means you failed because of attendance. So, which I have no control over. So I have a TA, and maybe raise your hand so people know who the TA is for this course. There she is sitting in the back there. She's the one that does the attendance. And believe it or not, I had a couple students who are brand new. So this is again for the new people. I had a couple students who were brand new last term. They didn't know that they were supposed to sign it, and the TA for the class wasn't her, it was somebody else. Didn't know, I guess, that he was supposed to. For like 3 or 4 weeks, they didn't get counted. And then they get this nasty message that comes from the university. It says, hey, you're not attending the class. And the guy's like, yeah, I've been here. It was an Asian guy. He's like, yeah, I've been here. What are you talking about? I'm like, yeah, I remember you. How come you're not signing the attendance? So the only thing you got to do, make sure you do as a student, is sign the attendance, especially if you're here. You want to get credit for it. It's not you signing it. I think she checks your ID, so you want to make sure you bring in your ID with you. And she checks your ID. Once after the first couple weeks, she'll probably just recognize you. After the first couple weeks, when you recognize them, you don't really have to check the ID, but you're just marking them. It's just one mark. Usually, I have them do it at the end of the course, at the end of the class meeting, because usually between now at the start and about 45 minutes into it, people just start showing up. I already know I have a couple people are going to be showing up later. So if we just wait till the very end and do it at the end. So this will happen around 12-ish. So you got to get here by noon, 12:30-ish, well, 12:45-ish, the latest. So, and then make sure you sign that attendance, because I can't do anything about that. It's out of my control. So it's the university that's doing that. It's because you guys are international students, and that's why you get the visa to come here, because you're supposed to be in class. So that's why they don't, it's not like an online class. Although, if you're interested in online in the fall, I'm going to be teaching some online classes here, and all international students are going to be allowed to take one class online. So, not a bad deal, actually, really. So, I don't know which classes are going to be offered yet. Don't ask me yet. We're just putting the program together. So what are we going to do in this class? Today, and probably again next week, because we still have students registering. So you guys are the lucky ones. I don't know what the capacity is, but I have a strange feeling we're going to get some more students in here. So I'll go over an introductory lecture today, but then next week will just be like the longer class meeting. So today we'll get out a little bit early. So, but this week is all about the preliminaries, introduction, overview, what operating systems are, what the class is going to be about. And lecture number 1, which is really chapter number 1 of the book, gives a nice overview of that. And that's really weeks 1 and 2. And then weeks 3 and 4 are going to kind of go into this whole process concept. What a process is, what a thread is, how processes and threads work in an operating system. Because really what we're looking at is multiple processes, multiple processing systems, which is the basis of a lot of the desktop systems that we're working with, Windows and stuff like that. It's all multiple process systems. So that's kind of a core concept of operating systems. And then CPU scheduling, and then looking not really much at the hardware, but looking at the software components and all the things, and I'll go through this when I start lecture number 1, but all the things that are housed inside of an operating system, all those subcomponents. And an operating system is just a program written in most likely C or C++, depending upon the operating system. And then we have the desktops that are right on top of this thing, and we have the kernel, and we have all these pieces and components. So that's really the focus of the first couple weeks. Talk about the components, figure out what we're working with. And then we have this thing called process synchronization, and some of the starvation, some of the deadlocks. Like when the window comes up in front of you, and it says waiting, or blue screen of death, all these things that happen with operating systems. We'll talk about that a little bit. That's like the synchronization issues, deadlock issues. And then we'll look at memory, the way RAM is used in an operating system, and then the way cache is used, cache memory, secondary storage memory, all sorts of different memory configuration, virtual memory versus physical memory versus logical memory. So you'll have a lot of memory stuff. And then we'll get into storage systems and file structures. File structure systems, the different types of linked file systems, hash systems, all sorts of different types of file systems. I guarantee it, by the time you get out of this class, you'll have a different feeling about operating systems. In terms of when you start looking and evaluating one operating system versus another, you'll probably start thinking more about, well, that's what makes it different, hopefully. So it should be a very enlightening experience. We'll look a little bit about protection and security, operating systems security. Not so much. It's not a security class, not an ethical hacking course or anything like that. It's just, just general operating system. It's a right good foundational course. After we get done talking about the base kind of system, then we'll get into some different types of systems, like the distributed operating systems, client-server systems, networking components of operating systems. which will be towards the end of the course here around week 12 and 13, which will probably, and then special purpose embedded operating systems, all sorts of different variations on the base model. And then we'll have a final review week. So right before the final exam at the end of the course, we'll have a class session that'll be dedicated, and you can actually see the final exam, and you can see the video I did for it. It's still uploaded on bhacker.com, and I'm going to archive that, put it under the previous term, kind of, not the previous term, but the previous week's, go back here. I haven't moved it over yet because, well, probably at my lunch break today I'll start the new video link for today's lecture. But then this stuff here, you'll see this, this is the review of what was on the, oops, not there, what was on the final exam. I think the video is probably still there. Yeah, the video is still there. And you'll see, this is a couple years old, but I'll archive it. I like to archive everything, actually. So we have that one, and we have a couple more years before that as well. So I think around 2008, 2009. 11, 12. So the class changes a little bit from term to term, but the information never changes. So if you're having a problem understanding something, you could just go back to like 2008 or 9 and work your way forward. Watch all those previous videos if you wanted to. I'm trying to organize them a little bit better, so we'll see how that works. But and as I mentioned before, over here I have like this program number 1 due, program number 2 due. There's no due dates. The due dates for the class will be at the very last day. So although when the EMS does become available and I'm able to load the class in there, then I'll put the due date as the very last day of the course. You don't want to wait until the very last day of the course, however. Just all those things I was saying earlier, you don't want to wait. And plus that's a lot of work. You know, especially if you're taking more than one class of mine, I have the same thing. Everything's due at the very last day of the class. Why is that? Because, you know, you guys all work, you all do stuff, you know, you have lives, you're adults, you know. I don't like due dates, personally, either. I like work at my own pace. You know, when I have something done, I just submit it. And I highly recommend, when you have it done, submit it. You know, don't like, because I had some students who had finished something and then they lost it, or they got deleted, or they just simply forgot to upload it. It's like, no, just upload it, get it out of the way, and you have it ready. Don't wait till the very last week. But this is a suggested guideline, which means the work for program number 1, I'll take a look at that in a few minutes, will be based upon weeks 3 and 4's material, which means around week 3 or 4, you probably want to start working on program number 1. And then in week 6, you can probably work on program number 2, etc. and so forth. So where are these programs? There's 5 of them. And they are worth 10 points, 5 points each, 25 points total. They're in the assignments link right here. So you see 1, 2, 3, 4, 5. Occasionally what I'll do is I'll build a video and I'll stick it under here if someone's having a problem with it. Or sometimes I'll go over the assignment and explain it. In fact, let me open up assignment number 1 here so you can see what we're looking at. And for this particular class, there's not very much pre-recorded stuff available for it because it's kind of more free form, like you can build it in other languages. This first assignment, however, just kind of gives you an example of, and this is probably the hardest one in the entire course, actually. So, which is the way I like to show. If you can do that, if you're not afraid of this one, the course is just fine for you. This is building a little shell. So you're going to build it in C or C++, well, most likely C, GCC. So, how are you going to do that? Well, you can get like one of those compilers that works in Windows, like Dev, C++. Or you can get, well, the problem here, though, is processes don't really work well in Windows. If you have a MacBook, you can program it in a terminal prompt. I'm going to try and work on Unix access for this class. We have access to new servers, and what I'd like to do is get logins for you so you can log into the server, like a Unix server, you know, and be able to like run GCC and stuff like that, which might not be a bad idea for an operating systems course, actually. So hold off. If you don't like this first assignment, hold off on it because it's the hardest one of the entire course. A lot of people do this one last. The next assignment, and I'm not going to go through, when we come through the schedule, I go through them a little bit slower than this. I'm just giving you an orientation to it. Let's take a look at the second one so you can get an idea what I'm talking about. The second assignment is not quite as many details. It's on CPU scheduling. So what you got is a description of it, and I don't expect you to read this, and I didn't read the first one either. So the first one, you're going to write a shell in C. And so that's going to be a problem because some of you may not have worked with C in centuries, or you may not even have access to a pthread library or something. I'm going to talk about threads though, so you'll figure out what it is I'm talking about in the next couple weeks. This next one though is a CPU scheduler. You probably don't know what CPU scheduling is yet either. Maybe you do. If you've taken an undergrad course in operating systems, you probably have an idea. But long story short, you're just going to create a simulation. You could do it in Java, you can do it in C++, you can do it in Visual Basic. The language is your choice. So it's only the first assignment that you can save to the last if you want, or it's only 5 points. If you didn't turn it in, you'd still get 95 points if you got an A and everything else. Ace the final. You can still end up with an A in the class without even doing that assignment. So, but you're probably going to do something for it, hopefully, because you don't want to like not turn it in, because that's like free points if you can turn it in. But the second one's going to be creating a CPU scheduler program. And the third one I think is going to be on memory management. So if we look at number 3 real quick here. Number 3 is going to be creating a memory management simulation. So what do we got here? We've got the ability here to look at, it's process synchronization. I think number 4 is going to be on memory management. So they're like one-page descriptions, and in the descriptions it'll go through, you know, create this and do this and do this and do that to it. So there's no other assignments, however, past this outside of the CSLO essay. So, but as we go through the schedule, I'll be going through those assignments a lot more detail. And then we'll actually sort of program some of the assignments in class. So one of the benefits you have of showing up on a regular basis is that we'll probably do all of the assignments in class, or most of them. So I see a lot of you brought computers, which is really good. Unlike some of the other programming classes I have, like the C++ and the, well, yeah, C++ or the Android or the iPhone stuff, which is all hands-on programming. This class is more lecture-based, and so is the EM class. Engineering management is more lecture-based. So we have the nice tables, however, hooked up. We have power, so it's not, you know, especially if you get bored of listening to me, you can go check your email and stuff like that. You know, it gives you something to do while you're in class. There's not going to be as many tutorials or as many hands-on exercises. If you've had other classes of mine before, it's going to be slightly different because there's more of me talking than there is anything else. So, which is why I like this class during the week instead of the weekend, because I can't do this all day. I mean, a couple hours is my max on talking, so. Alright, so that, what I just gave you was kind of a brief overview of the course and of the syllabus and where to find the materials for the course. And you'll see in here there's this little CSLO essay. I'll go over that later on. It's just going to be an essay that you're going to write, 2 or 3 page essay, you know, writing assignment. Why? Because you're graduate students and it's a great opportunity to get some more practice writing. This stuff in here, these are all PowerPoints. I bring them up in a preview program, however, I don't run them in PowerPoint because I don't have PowerPoint installed on here, but they work in PowerPoint. And there really isn't anything else on here. There's not that many examples or anything. I might populate it a little bit as we go through the course, especially when we start looking at the assignments. But I kind of cleaned it out because I hadn't taught this course in, like, well, since 2011 was the last time I taught it, a couple years ago. So I'm in the process of revamping it a little bit. So. Questions on the syllabus or on the course? Now that we all know what we're here for. I thought it was going to be engineering management. We got engineering management too? That's okay. No? You don't. It's at 2 o'clock? Yeah. Okay. But it's because I have to go back here now and reorganize this main menu because I had an engineering management at 11. So I'll switch this one. So C++ is on the weekend then. Yeah. Okay. So I'll fix that. And the other thing too is you can probably look in the previous course section, but you don't need to. Previous course section is not going to have anything. Well, it has Unix operating systems in there, but you can see I archive everything on here. So if you have anything from a previous class or something like that you're interested in, probably check it out. If you don't have any questions, then I'm going to go into lecture number 1. Yeah? And we have a problem? What is that problem?
Website is not open.
My website's not open? Oh, yes it is. Watch this. It's not open for you, but it's open for me. It's working.
Net is connected, but it's showing me the error.
Oh, you know what? The internet around here is not such a reliable thing these days. I would reconnect and connect and reconnect. Were you able to get a connection at all today?
Yeah, I got the connection.
Okay, you just
I
lost it.
restarted the computer also.
Oh, okay. Well, it's possible. I seem to have a connection myself right now. It's possible that I'm going to lose it. So it's I believe they're in the process of upgrading. Oh, I better have downloaded then. Yes, I did download. That's good. They're in the process of upgrading the internet speed. I think with the new online registration system and some of the new things that they have going on, that we're lagging a little bit with speed. So, all right. So what I'm going to do is give you guys a break, stop, not a break, but I hate saying that word. Break this lecture recording and start fresh with this next one here. So I'm going to stop this.